Hi everyone, in this lesson we're going to talk about polynomial identities. So this is kind of an extension to factoring, and these first two you've seen before. These you probably haven't, so it is going to take some practice, so please don't panic if you see it for the first time and you're a little stressed out. We will practice it and we will talk about it some more, not just this video. So to start, difference of squares. We've seen this, we know it, we love it. It says that if we are squaring two things and we have a subtraction, so difference, then the factored version is going to be a plus b and a minus b. So you just take the square root of both, you have a plus version and a minus version. The square of a sum, so if you're adding two things and then you square it, remember you can't just distribute that exponent if you have a plus or a minus inside the parentheses. So this is equal to a squared plus 2ab plus b squared. So you would take a and square it, that would be your first thing. Multiply these two together and then multiply it by 2, that would be your middle term. Take the last term, square it, that's the end. This is what's going to be new, okay? So difference of cubes says that if we are cubing two things and we are subtracting, then the factored version is a minus b. All right, so cube root both, and then you have a minus b. This is where it gets a little bit tricky. Then we have a squared plus ab plus b squared. So again, we're going to practice this, but we start off with just cube rooting both, minus, and then we would actually take these numbers and square them to get the ends here, and then multiply them to get the middle. Sum of cubes is similar, it just has a few minor differences. So instead of a minus b in your first parentheses, you're going to have a plus b. And then in the second set of parentheses, we're going to have a squared minus ab plus b squared. So one thing to note about both of these cubes is that each one only has one minus sign. So if we are subtracting, the minus goes first. Everything else is positive. If we are adding, we start with a positive, but then we have this minus on the middle term so that it'll cancel out. Okay, so again, we're going to practice with these. I'm going to show you some examples now, and I'm going to keep this off to the side here so that hopefully we can kind of see it while we're working. So we're going to start off with multiplication. And the reason we're going to do this is because hopefully you notice it looks a lot like our sum of cubes. So we're going to multiply this out and kind of see why it works. So we talked about multiplying yesterday. We're going to distribute everything in the first set of parentheses to everything in the second set. So I'm going to just start with distributing a. All right, a times a squared is a cubed. Minus, we have a squared b, because a times a gives you a squared, then you have the b, plus a b squared. Looks a little funky, but it's all right. Now we're going to distribute b, and I always like my terms to be in alphabetical order, so even though it looks like it should be b a squared, I'm going to actually do my a squared first, and then b. Distribute there, so minus, we have 1a and then b squared plus b cubed. All right, now we're going to combine like terms. So we have a minus a squared b, and then here we have the same term, a squared b. We have a minus 1 and a plus 1, so these cancel out. Then we have ab squared minus ab squared, same variables, same exponents. Once again, they cancel out, and we're left with a cubed plus b cubed, exactly what our sum of cubes says. Okay? All right, so let's practice going backwards. We are going to factor x squared, or x cubed, minus 125. So whenever you're factoring something with two terms, I want you to figure out, can you either square root or cube root both of the numbers, or both of the terms? Well, on here, the answer is yes, because if we cube root x to the third, we would get x. If we cube root 125, we would get 5. All right, so we have two cubes and it's a difference. So we're going to use our difference of cubes formula there. Okay, well, in order to do that, we have the cube root of both, and then we also need to find the squared version of both, and we need to multiply. Okay, so let's say this is our a term. Okay, so we need to be able to square it. So if I take x squared, we get x squared. We're also going to square this one to get 5 squared, which is 25. Let's see what happens here. I'm going to use this formula, okay? So it says to do a minus b. Well, that's going to be x minus 5. So that's the very first thing we're going to have. We're going to have x minus 5. It's just the cube root of both of our terms. This second parentheses is where it gets a little bit tricky. We want to take that first number inside these parentheses, that x, and square it. That's going to be x squared. Then it says to do plus, and it wants us to multiply these together. So x times 5 would give us 5x plus, it wants us to do b squared. Well, b is 5, so squared is 25. And this is the factored version. Okay, if you were to multiply this out, again, like we practiced yesterday, you ended up with x cubed minus 125. So we're following these formulas. Okay, let's try another one. So if we have two terms, let's figure out, could we either square root or cube root? We have even exponents, so we're not going to be able to cube root, but let's try square rooting. So if I square root x to the 10th, I would get x to the 5th. So when you square root, you're basically just dividing that exponent by 2. If we were to cube root, we would divide it by 3. Let's find the square root of 36y to the 4th. The square root of 36 is 6. The square root of y to the 4th, again, divide that exponent by 2, and we get y squared. All right, so we have a difference, we have a minus sign, and we have two perfect squares, so we're going to follow this formula. So we're going to have our parentheses. We're going to have x squared plus, oh, I'm sorry, x to the 5th. I don't know what I'm doing there. X to the 5th plus 6y squared. So taking these square root terms, x to the 5th plus 6y squared. And then we're going to do x to the 5th minus 6y squared. So following our difference of squares formula, we get our answer. This one is definitely less complicated than the cubes, and we've also seen our difference of squares before. All right, sorry for the jump in the video. I may or may not have messed up. I will never admit it. However, we have one more problem to do. So we have two terms, okay? We got to figure out, are they squares or are they cubes? So we have an odd exponent, so it's definitely not going to be difference of squares because we can't divide that by 2 and take the square root. So let's try to take the cube root of both. So we're going to take the cube root of 27 x to the 12th. So the cube root of 27 is 3. 3 times 3 times 3 gives you 27. Then we're going to take 12 divided by 3 when we're cube rooting those exponents. So we're going to get 3x to the 4th. We're then going to take the cube root of y to the 3rd and get y. Okay, so we can take the cube of both. That means we have cubes. Since there's a plus, we're going to be using our sum of cubes equation. So we're going to start with the easier part, which is that first part. So our a term is the cube root of the first one, so 3x to the fourth. Since it's a sum, we're going to have plus in this first set of parentheses, and then we take the cube root of our second term. All right, here's where it gets a little more complicated. So we're going to have to take the a, that first term in our first set of parentheses, and square it. So 3x to the fourth squared. Now, since this doesn't have a plus or minus in it, we basically get to distribute the exponent. So 3 times 3 gives us 9. And if we had x to the fourth times x to the fourth, that would give us x to the eighth, because we would have 4 x's twice. That would give us 8 x's. All right, so that's going to be the first term, 9x to the fourth to the eighth, which is definitely what I wrote down. All right, then our sum of cubes has a minus next, and then we're going to multiply our first terms together. So 3x to the fourth times that second term, which is y. Okay, then we have plus. Then we want to take our second term, this b right here, the y, and we want to square it. So we're going to do y squared to get y squared. And that gives us our factored form. All right, so that is how we factor a sum of cubes and a difference of cubes. The only thing we didn't do in this video is the square of a sum, and we will practice with that eventually. Okay, these you will need to know. All right, so make flashcards if you want. I'm going to post a Quizlet of them if you want to study it virtually. And here are, oh, see, there it is. Here are our examples. Please feel free to watch this as many times as you need. If you have questions, please let me know, but I would really encourage you to write these down, pause it, take a picture, and we will practice more with our polynomial identities.